Hey, what's up YouTube? Dr. T here in St. Petersburg, Florida. In previous 2-minute papers, we covered the basics with convolutional neural networks, recurrent neural networks, and a combination of the two. Now it's time to step up our game and take a look at a defining point in time for AI, namely the publication of the DeepMind Atari game work. You're looking at the annual Formula One road race that is staged in St. Petersburg, Florida. Just about to happen when they're going to shut the town down for a few weeks.
Dear fellow scholars, this is 2-minute papers with Károly Zsolnai Fehér. This one is going to be huge, certainly one of my favorites. This work is a combination of several techniques that we have talked about earlier. If you don't know some of these terms, it's perfectly okay. You can remedy this by clicking on the pop-ups or checking the description box, but you'll get the idea even watching only this episode. So first, we have a convolutional neural network. This helps processing images and understanding what is depicted on an image. And a reinforcement learning algorithm. This helps creating strategies, or to be more exact, it decides what the next action we make should be, what buttons we push on a joystick. So this technique mixes together these two concepts, and we call it deep Q learning, and it is able to learn to play games the same way as a human would. It is not exposed to any additional information in the code, all it sees is the screen and the current score. When it starts learning to play an old game, Atari Breakout, at first, the algorithm loses all of its lives without any signs of intelligent action. If we wait a bit, it becomes better at playing the game, roughly matching the skill level of an adept player. But here's the catch, if we wait for longer, we get something absolutely spectacular. It finds out that the best way to win the game is digging a tunnel through the bricks and hit them from behind. I really didn't know this, and this is an incredible moment. I can use my computer, this box next to me that is able to create new knowledge, find out new things I haven't known before. This is completely absurd. Science fiction is not the future. It is already here. It also plays many other games. The percentages show the relation of the game scores compared to a human player. Above 70% means it's great, and above 100% it's superhuman. As a follow-up work, scientists at DeepMind started experimenting with 3D games, and after a few days of training, it could learn to drive on ideal racing lines and pass others with ease. I've had my driving license for a while now, but I still don't always get the ideal racing lines right. Bravo! I have heard the complaint that this is not real intelligence because it doesn't know the concept of a ball or what it is exactly doing. Edgar Dijkstra once said, "The question of whether machines can think is about as relevant as the question of whether submarines can swim." Beyond the fact that rigorously defining intelligence leans more into the domain of philosophy than science, I'd like to add that I am perfectly happy with effective algorithms. We use these techniques to accomplish different tasks, and they are really good problem solvers. In the Breakout game, you, as a person, learn the concept of a ball in order to be able to use this knowledge as a machinery to perform better. If this is not the case, whoever knows a lot but can't use it to achieve anything useful is not an intelligent being, but an encyclopedia. What about the future? There are two major unexplored directions. The algorithm doesn't have long-term memory, and even if it had, it wouldn't be able to generalize its knowledge to other similar tasks. Super exciting directions for future work. Thanks for watching and for your generous support, and I'll see you next time.
Well, I hope you enjoyed that. With some relevance, I'm just about to come to the end of the coding problem that I've been working on, namely the grid world. There's a little bit more to do, but basically the problems have been kind of overcome. And that will be my short venture into reinforcement learning, although there's still plenty more to read and background stuff to cover. But the next step is going to be moving up to this area, deep Q learning or otherwise deep reinforcement learning, and somewhere along the way this is going to be a problem I'm going to have to face, because I don't think one can go forwards in this area without tackling this particular topic. So lots of work out ahead of me, and as always, when I finish coding a project, you will have the opportunity to learn how it's done line by line. If there's enough support, I will definitely go through it. So I hope you enjoy this 2-minute paper and look forward to the next one, and I'll see you next time.